Welcome, Honors Algebra 2, to our first video. Super exciting. So today we are going to start, we're not going to finish, but we are going to start R5. Chapter R is basically a review chapter. We kind of bounce, this entire section is going to be review from prior units, except probably one thing is going to be new. But for the most part, maybe a few things, but for the most part, a lot of this is going to be review of stuff that you have learned in Algebra 1. So we really bounce around in this section. So I'll just label them as we go through. So we are going to start with just a review of factoring. And I am sadly not doing this in my notebook. If I did have my spiral right now, which I don't, but I wanted to make the video for you guys, I would have put this would be on my first page of my spiral. And that would be kind of my starting point and keeping my spiral organized. So if you do have a spiral, great. If you don't have a spiral, maybe pause the video and get a spiral. I will have a spiral in the next video. So, okay, we are going to talk about different methods of factoring. So we're going to talk about 3 different methods of factoring. All of these should be reviewed from Algebra 1. So really the most important thing to remember with factoring is always first check for, hopefully you're thinking, coming back to you, always check for the GCF first. So that's going to be always your first thought whenever you are factoring. So always check for a GCF. Okay, so let's actually start there with GCF and just factoring out the greatest common factor. Remember, that's what GCF stands for. GCF stands for greatest common factor. So it's a number or a number in variables or just a variable that divides evenly into every single term that you have there. So when we're factoring a GCF, like I said, that's always the first step. And really, it can be any number of terms. It can be 2, 3, 4, unlimited. So any number of terms. This method works with any number of terms, except I guess 1. But so we're just going to dive into examples. So my first example would be to factor 3x cubed plus 9x squared. Now, if you are seeing this and you're like, I'm super confident in myself, I'm so good with factoring, I don't need a refresher, awesome. That's great. You guys can try these problems on your own and then just come back and check to make sure that you got them correct. So that's what you can do. So you can pause me, fast forward, do what you need to do. But if you don't feel comfortable with it and you need that refresher, I'm going to go through it right now. So looking at, first I look at the numbers. I look at the 3 and I look at the 9. And I think, okay, what number divides, if any, divides evenly into both 3 and 9? And that would be 3. I always kind of look at the smallest number first and I think, does 3 go into 3? Yeah. Does 3 go into 9? Yes. So I can factor out a 3. And then I look at my variables, x cubed and x squared. Now I look and I think, do they both have an x? And they do, they both have an x. So then I think about factoring out which, the smallest of the 2. Now there's 3. I can't factor out 3 from here, but I can factor out 2 and I can factor out 2 from there. So I just take the smallest exponent. So my GCF is 3x squared. And then what's inside the parentheses, it's what's left. So 3 divided by 3 is 1. X cubed divided by x squared is x. 9 divided by 3 is 3. And x squared divided by x squared is 1. So that is it. We can always check our work by distributing back in. So 3x squared times x is 3x cubed. And 3x squared times 3 is 9x squared. So that is my answer. Now I know that it's fully factored, but I always go back and look at what's left inside and I think, can I actually factor that further? And I can't. X and 3 don't have a GCF, so that would be my final answer. Okay, so let's move on to number 2. So what I want you guys to do, fold it in half. I don't know why I'm doing this. I'm going to recopy it into my spiral because that's who I am. But I like to have it even. Okay, so on number 2, what I want you guys to do is look at this example. So 15x cubed y squared minus 10x squared y plus 5xy. So I want you guys to look at that, and I want you guys to see first, can you do this one on your own? And if you're feeling good, if you're feeling confident, pause me here and try this problem on your own. Okay, so hopefully you've tried it on your own and you're just coming back to see if you did it correctly. If you are just wanting to check it, go ahead, fast forward me and check it and see if you did it right. If you need to, watch me go through this one, I'll go through this one again. Okay, so 15x cubed y squared. So I really just start by looking at the numbers, 15, 10, and 5. And I, again, like I did over here, I look at the smallest number and I think, does 5 go evenly into 10 and 15? And it does, so I can factor out a 5. Then I look at the next variable. Do they all have x's? Yes, they do. So I take out the smallest one, 3, 2, 1. The smallest one is 1. And then do they all have a y? Y2, y, y. And they all have a y, so I can factor out a y. And then I want to think about what's left. So 15 divided by 5 is 1. X cubed divided by x is x squared. And y2 divided by y is y. Okay, and then we move to the next one. Negative 10 divided by 5 is negative 2. Keep the sign. X squared divided by x is x. Y divided by y is 1, so it goes away. And then we're left with, okay, so 5 divided by 5 is 1. X divided by x is 1. Y divided by y is 1, so we just leave it as 1. Now, what's really important and probably one of the most common mistakes is when you're like a GCF is taken out, like 5xy was our GCF, you still need to put that 1 there. If you didn't, you wouldn't get the same thing when you multiplied it back together. So what's inside the parentheses, the number of terms that you start with should always be the number of terms that's inside the parentheses. So there's 1, 2, 3. There should be 1, 2, 3. And that is fully factored. Okay, so that's GCF. We're going to talk a little bit more, I think, about GCF throughout, but GCF is kind of like your starting off point. You're always looking for a GCF to begin with. The next thing we're going to talk about is difference of squares. So difference of squares is pretty straightforward. I think as the year goes on, my handwriting gets better. It's like when I first start, it's like I haven't written notes in a while. Okay, so difference of squares. For something to be a difference of squares, remember, for one, the number of terms. So up above here, we talked about we can use the GCF method on any number of terms. Now, difference of squares, we use this method only when there's 2 terms. Now, those 2 terms have to be specific. So those 2 terms have to be both perfect squares and they have to be subtracting. So it's 2 terms that are perfect squares. Oh, okay. And subtracting. Hence the difference and the squares. Now there's kind of like not a rule, but kind of like a formula. I don't know if that's a word I want to say, but there's a pattern. Let's go with pattern. I like that. So if you have a squared minus b squared, so you have 2 terms, 1, 2, there's subtraction in between, And this is a perfect square, a squared is a perfect square, and b squared is a perfect square. Now, if you're wondering what does a perfect square mean, that's basically like 64 is a perfect square because 8 times 8 is 64. 49 is perfect square because 7 times 7 is 49. 36 because 6 times 6, and so on and so on. So it's something that you can easily take the square root of. So what we're going to do is we're going to look at a squared and think, what's the square root of a squared? The square root of a squared is a. So what we can do is whenever there's a difference of squares, you're always going to factor it into 2 parentheses. And so the square root of a squared we know is a. So we're going to have a and a. And then we think, well, what's the square root of b squared? The square root of b squared is b. We're going to have b and b. And then 1 is adding, 1 is subtracting. So hopefully you guys remember that one, that pattern that you guys should have learned in Algebra 1. So that one's really important. We see this one a lot, and it's pretty common. So what we would do, that's it. And really, you can use this on anything. So a squared minus b squared, if it was x squared minus 49, that would be x plus 7 times x minus 7. X squared minus 64 would be x plus 8 times x minus 8. So that is really your pattern. If you know this, then you know how to factor any difference of squares. So let's look at another one. Okay, so what if I gave you x to the 4th minus 16? And I said factor that. So I want you to think, looking at number 3 and knowing what you know about square roots, what would be the factored answer for x to the 4th minus 16? If you need to pause me when I say, think about what this is, then pause me there. I'm not going to have that built in because no one wants to hear me breathe. So I'm going, pause me when you need to pause me. Okay, so x to the 4th minus 16, I think about, okay, what's the square root of x to the 4th? So the square root of x to the 4th, remember, and I'm actually going to write this over here. So if I take the square root of x to the 4th, remember, a square root is the same as a fractional exponent. It's the same as me saying this. So x to the 4th raised to the 1/2. And we know with an exponent to an exponent, we multiply. And 4 times 1/2 is 2. So the square root of x to the 4th is x squared. So we can kind of set it up and put x squared and x squared. And then I move on to my second term, 16, and I think, what's the square root of 16? The square root of 16 is 4, so I'm going to put a 4 and a 4. One's adding, one's subtracting. Now, remember what I set up above here and with here. I think, can I keep factoring? And so I want you guys to think to yourself, on either one of these, can you keep factoring it? And if you're thinking yes, oh, someone's calling me. I'm sorry. I'm going to pause them, or I'm going to decline their call. So if you're thinking yes, you're right. And now we're thinking, okay, well, which one is factorable? Which one can we factor further? X squared plus 4 or x squared minus 4? And the answer is both of these are perfect squares. X squared and 4 and x squared and 4 are both perfect squares. But one of these is a difference of squares, x squared minus 4, because of that minus in between. So x squared plus 4, when it's a plus in between, it's no longer a difference of squares. That is not factorable. Let me rephrase that. You cannot factor that further. So x squared plus 4 stays as is. But what doesn't stay as is, what you can factor further, is this x squared minus 4. So what we're going to do is just bring this down. And then we're going to apply difference of squares here. So x squared minus 4, what's the square root of x squared? What's the square root of 4? And so that would be x plus 2 and x minus 2. So again, I think, can I factor anything further? We're always thinking, can I factor further? Can I factor further? And in this one, the answer is no. So that would be my final answer. So remember, this was a difference of squares that we broke up here, and then this, we can keep factoring it further. Okay, so let's actually try one more difference of squares. I'm going to put that right here. 5, yep, okay. And so that would be 9x to the 6th minus 25. So I want you guys to pause me here, try this one on your own, see if you can do this, and then come back and check your work. Okay, so hopefully you've tried, you're coming back, you're checking your work. I would start by thinking, okay, is 9x to the 6th a perfect square? And it is. Is 25 a perfect square? And it is. So I can split it into my two parentheses. So 9x to the 6th, if I take the square root of that, remember, again, if we circle back to this being like a fractional exponent where it's to the 1/2, you're just, whenever you're taking the square root of an exponent, you're basically dividing it by the root. So if it's square root, you're dividing it by 2. If you're taking the cube root, you're dividing the exponent by 3. If you're taking the 4th root, the exponent by 4. So it's always the exponent being divided by the root, not the actual number. That we just do as normal. So the square root of 9x to the 6th is 3x cubed. 6 divided by 2 is 3. Square root of 9 is 3. And then the square root of 25 is 5. And so factored would be 3x cubed plus 5 and 3x cubed minus 5. Now, if you're wondering, does it matter what order you put them in? These matter what order you put them in. The 3x cubed and the 5. The first term has to go in the first spot. Second term has to go in the second spot. But you can put the plus factor first and the minus factor second, or you can put the minus factor first and the plus factor second. It doesn't matter. That would get you the same thing. Now remember, every single time with factoring, you can always check by multiplying it back together. If you get the problem was, what you started with, then you're great. Then you're right. Okay, so those are my first two. We're going to keep going. My third method is grouping. Grouping is super important. So with grouping, difference of squares was when we had 2 terms. Grouping is when we have 4 terms. Okay, so with the 4 terms, I'm just going to rearrange it so you guys can see it. When we have 4 terms, so with grouping, what number am I in? 6. Okay. So if I gave you 3x cubed minus 15x squared plus 2x minus 10, and I said factor that. So with the grouping method, and we're only going to do one example here because we're going to do a lot more examples that are going to use grouping in a minute. What you do and why we call it grouping is we split it into 2 groups. So we look at the first 2 terms as one group. So 3x cubed minus 15x squared is one group. And then we look at 2x minus 10 as the second group. So now we're using what we did in the first category, GCF. So I look at 3x cubed minus 15x squared, and I think, what's the GCF there? So I'm thinking between 3 and 15, I can factor out a 3. Between x cubed and x squared, I can factor out an x squared. And what's left? So 3 divided by 3 is 1. X cubed divided by x squared is x. Negative 15 divided by 3 is negative 5. X squared divided by x squared is gone, is 1. Now, What's important is you guys always take the middle sign and bring that down. So if this is a plus, we bring down that plus. If it was a negative, we'd bring down that negative. So this sign always comes down. And then I start again. So what's the GCF between 2x and 10? Well, it's 2. So 2x divided by 2 is x. Negative 10 divided by 2 is negative 5. So now we look at it now as a whole expression. And I look to see, are these the same? X minus 5, yes. And so what you're actually doing with this next step is you're factoring out a GCF. So you're factoring out the GCF of x minus 5, and then you're looking at what's left. So if I factored out x minus 5 and x minus 5, what's left is 3x squared plus 2. And so that goes in the second parentheses. And that's it. That's your answer. I look to see, which I already know the answer to, but I look to see, can I factor either one of these further? I can't, so I leave it as is, and that's my final answer. Now, grouping, I'm only going to do one example of this, and the reason is because we use grouping for our next method as well, so I'm going to still kind of embed it in our next examples. So our last method that we're going to talk about is splitting the middle term. Now, if you guys did not take algebra here, you might not have seen this method. So if you are more comfortable with a different method, that's totally fine, but make sure you are super comfortable with it. If you are don't have a method that you're comfortable with this, then just follow along with what I'm doing because it works every time and it always is pretty straightforward. Okay, so this last method is split the middle term. I don't know if there's a better way to call this, but that's what we call it here. So split the middle term. Now we use this method when there are 3 terms. And we use this one a lot. So I'll give you an example. So an example of a 3-term expression that we can factor would be something like 6x squared minus 7x minus 3. So to factor this, I'm sure a lot of you guys are used to thinking about, okay, set up that big X. And some of you are like, oh yeah. So don't worry, you'll get super used to factoring. I feel like that's a weird threat. It's not meant to be, but you just get used to it. So on top is what you're going to do is you're going to take A and multiply it with C. So what it's going to be is 6 times negative 3. And 6 times negative 3 is negative 18. And now the bottom is going to be my B term. My B term is negative 7. So negative 7 is going to go in the bottom. Now remember, hopefully where it's all of a sudden that Algebra 1 moment is flooding back to you and you're remembering all those things that you started remembering. We're thinking what multiplies together, what 2 numbers multiply together to get me negative 18 and add to get me negative 7. So pause for a second. I want you guys to think of those 2 numbers. What are 2 numbers that multiply together to get me negative 18 and add to get me negative 7? And if you're thinking negative 9 and positive 2, you would be correct. Because negative 9 times positive 2 is negative 18, and negative 9 plus 2 is negative 7. So here's where splitting the middle term comes into play. So 6x squared, not my middle term, stays exactly as is. My middle term is negative 7x. So we're going to take these 2 numbers that we just came up with, negative 9 and positive 2, and we're going to split the middle term. So instead of writing negative 7x, we're going to write negative 9x plus 2x. Now, I know some of you guys are wondering, does it matter what order these go in? And the answer is no, it doesn't. What I usually do, and for this one, it doesn't really matter, but what I usually do is I think, what goes better with 6, 9 or 2? And then I think, okay, what goes better with 3, 9 or 2? And so whichever one goes better with whichever one is the order. But no matter, it doesn't matter. You could put in any order and you'll still get the right answer. And then we bring down that minus 3. So notice we just split the middle term. Negative 7x is the same as me writing negative 9x plus 2x, because if I combined those, that would still get me negative 7x. So it's the same expression. It's just now 4 terms. And I think, well, what method do I use when there's only 4 terms? And remember, that's grouping. So we go back to what we did up here. So I split it into 2 groups, 6x squared minus 9x, and then 2x minus 3. And I look to see what's my GCF between 6x squared and negative 9x, and that is 3x. Oh, I'm going to run out of room. 6x squared divided by 3x is 2x, and negative 9x divided by 3x is negative 3. Bring down that middle sign so that plus comes down, and I think, what's my GCF between 2x and minus 3? Well, there isn't one. Nothing divides evenly into those. But what number do we know divides evenly into every single number? And if you're thinking 1, you'd be correct. 1. And so 2x divided by 1 is 2x. Negative 3 divided by 1 is negative 3. And if you notice, just like up here, that x minus 5 and x minus 5 were the same. 2x minus 3 and 2x minus 3 are the same. So we can write it as 3x plus 1 times 2x minus 3. If you wrote it as 2x minus 3 times 3x plus 1, same thing. So I'm hoping this is kind of coming back to you. You're feeling good about doing those problems. So what I'm going to have you guys do, I'm going to give you guys this one, and I want you guys to try this one on your own. Okay, so this one is going to be 2x squared plus 13x plus 15. So I want you guys to try this one on your own. So pause me here, try it on your own, and then come back and check your work. Check to make sure you did it correctly. Okay, so hopefully you're coming back, and I'm actually going to do this one a little bit quicker. I'm not going to explain the whole thing. So if there are questions, if you're coming up with questions while you're doing this, we'll have time to go over questions in class. So that would be a good time, like write down notes to yourself, write it on a Post-it, write it on your notes, and then bring those questions to class so we can go over it together. So the first thing I would do with this step is set up my x. So I'd set up my x, and I'm going to do that right now. Okay, so I set up my x. 30 is on top, 2 times 15. 13 is on bottom, which is my b term. And I'm thinking, what 2 numbers multiply together to get me 30 and add to get me 13? And that would be 10 and 3. And those are my 2 terms I'm going to use to split the middle term. So I'm going to do that one next. So now I split the middle term. Remember, it really doesn't matter which one you put where. If you would put the 3x first and then the 10x second, you should still get the same thing. And if you're doubtful of me, then try it on your own and see and make sure you get the same thing. So then I have 4 terms, so I'm going to factor by grouping. So I'm going to do that next. Okay, so now that I factored by grouping, I double check, are my parentheses the same? And they are, so we're good. And I can write my final answer. So I have 2x plus 3 and 1 and x plus 5 in my second parentheses. And that is it. You're still always checking to make sure, can I factor these further? You can't, so you're good. Okay, we're going to do 2 more, and then we're going to be done. Okay, I'm going to flip this, so if you need anything on this, then pause me. I'm going to flip it. I need to remember what number I am on. 9. Okay, so I'm going to actually give you guys kind of an easier one. So I'm going to give you guys x squared plus 13x plus 42. Now with this problem, a lot of you guys know that there's a shortcut. Some of you guys are like, I don't remember the shortcut. Will you refresh my memory? And I will. But this one, what I want you guys to do is start it off exactly the same as we did with both 7 and 8. And so what you would do if we were doing this exactly the same is we'd set up our x. I'd multiply a times c, which a is 1. 1 times 42 is just 42. And then my b term goes still in the bottom, 13. So I'm thinking what two numbers multiply together to get me 42 and also add to get me 13. And if you can't think of them, pause me here, try it on your own, think about it on your own first. And if you got them already and you got 7 and 6, you would be correct. And so now we can use those two numbers to split our middle term. So x squared stays as is. 13x doesn't really matter. We're going to split it up in any order, 7x and then 6x. And then our last term, 42, stays as is. And so now I can factor by grouping. So I can factor this one, split it up, just like I did on the prior two problems, and factor a GCF that way. So my GCF between x squared and 7x, I can factor out an x, and I'm left with x plus 7. Remember, you always bring down your middle sign. So we bring down that plus. 6x plus 42, I can factor out a 6, and I'm left with x plus 7. And so now, are these the same, x plus 7, x plus 7? Yes. And so I have x plus 7 times x plus 6. And that's my final answer. Now, if you're wondering, well, what was that shortcut? Well, if you notice 7 and 6, when a is equal to 1, you can go from here straight to here. You don't have to do this in between. You do have to do the in between when a is not equal to 1. So when there's that 6 and that 2, that's when you have to use, oh, you couldn't even see that, when there's that 6 and that 2, you have to split the middle term. When a is equal to 1, you do not have to split the middle term. Okay, one more problem, and that will be it. Okay, last one. 4x squared minus 18x minus 10. So if you're feeling good, feeling confident, I want you guys to pause me here, try this problem on your own, and then come back and check your work. Okay, so hopefully you're checking your work. Now there are really two ways to do this problem. And I'm going to start with what I would have done. So I would have seen 4, 18, and 10 and thought, wait, 4, 18, and 10 are all divisible by the same number. They're all divisible by 2. So I can actually first factor out a GCF, which is 2. And I'd have 2x squared minus 9x minus 5. And you're thinking, oh, I didn't do that first. That's okay. Hopefully you'll get to the same answer. So all I did here was just first factor out a GCF. And then now this should be something you guys can do. It's just like number 7 and number 8. We're going to split the middle term. So I'm actually going to do that problem. I'm not going to explain it through. I'm just going to kind of show the steps. So I just started by setting up my big X. So A times C is on top and B is on bottom. My two numbers that multiply together to get me negative 10 and add to get me negative 9 are negative 10 and 1. And so those are the two numbers I'm going to use to split my middle term. So I'm going to ignore the 2 for right now and just split my middle term. So I'm going to 2x squared minus 10x plus 1x minus 5. Again, it does not matter what order you put that in. That minus 5 should have been a darker blue. And then I can factor by grouping. So 2x squared minus 10x, I can factor out 2x, and I'm left with x minus 5. I always bring down my middle sign, plus 1x minus 5. There's no GCF. Remember, what's the GCF? You can always factor out 1. And I'm left with x minus 5. Are these the same? Yes, that's what we wanted. So I have 2x plus 1 and x minus 5. But wait, what do I need to bring down from the beginning is that 2. So that 2, even though I ignored it, I can't forget it at the end. Because if I were to multiply if my answer was just 2x plus 1 times x minus 5, and I multiplied that together, that would get me 2x squared minus 9x minus 5, not this 4x squared minus 18x minus 10. Now, if your answer was 4x plus 2 times x minus 5, you can factor that first parentheses factor further. If your answer was 2x plus 1 times 2x minus 10, you can factor that second one further. So always be thinking about a GCF. This is your final complete answer. Okay, that's it. Those are the notes. Remember, as you guys are going through these, hopefully you're writing down questions. Bring them to class. We'll go over those and go from there. So I hope you guys have a great rest of your day, and I will see you guys soon. Bye, guys.